Hello and a very good afternoon. Welcome to today's webinar on Quarch Compliance Suite, QCS for short, mandatory for UNH-IOL, NVMe Plugfest with Quarch Solutions. We still have attendees joining in, so we'll wait for a couple of minutes before we start the session. Request all of you to stay tuned in. Hello again. Thank you for waiting. I'm Nana Patil, Technical Lead at Electro System Associates, ESA India. So the webinar today is being hosted by ESA India to present fully automated compliance suite, QCS, Quarch Compliance Suite from Quarch Technologies. QCS comes with UNH-IOL Plugfest test suite for both SAS and NVMe devices, covering the foundations of HOTPLUG compliance testing. Quarch products are the industry standard for HOTPLUG and fault injection testing, which are mandatory for UNH Plugfest compliance testing. Today from Quarch, we are pleased to introduce Mr. Andy Nouri, co-founder and director of operations, and Mr. Matt Jose, lead engineer, Quarch Compliance Suite. They'll be the presenters in today's webinar. In today's webinar, we'll present Quarch solutions for performing a wide range of completely automated tests with QCS to qualify your storage devices quickly by running various test cases, including power analysis, HOTPLUG, pin bounce, and timing tests to ensure your system is stable in all cases and it can handle the most likely physical layer faults that might occur in the field. ESA is Quarch's local India partner responsible for sales and technical support. We'll get started with the session now. We would like to make the session very interactive. We'll be taking questions along the way instead of waiting till the end of the session. So we encourage all of you to leave as many questions as you have in the chat box. The webinar is being recorded and will be made available to all the attendees. Andy, we welcome you to begin the session.
Thank you, Nina. I appreciate the introductions. It's good to be here. So, first of all, your thanks to ESA India for setting up this call. We really like to get in front of customers to share what we've been working on over the last few years and also to get feedback from you as to what else you need from us in the future. So myself and Matt will be taking you through a bit of a trip into HOTPLUG testing, the importance of it, and the requirements for the UNH HOTPLUG test in particular. So a little bit of an introduction initially. The University of New Hampshire's Interoperability Lab many of you probably know about. It runs Plugfest events. And the idea of these is that companies designing drives, hosts, and other equipment for the industry, such as analyzers, cables, and adapters, can all get together and prove the compatibility of their equipment and prove that they meet the industry standards that are necessary. Now, we've worked with UNH for many years now, and our research led to the requirement of mandatory hot plug testing during these events. The reason for this is that hot plug is a complex action with many potentials to go wrong because you are plugging in pieces of equipment that are powered up and running. Quarch tools have provided a simple automated means to complete these tests. So whilst basic hot plug testing can be done by just physically removing and inserting a device, it's not very repeatable, it's not very simple to perform, and you're not really doing a very detailed test of your system. So why test hot plug? Basically, hot plug is a complex action with a lot of potential for failure. It seems very simple. You're simply pushing a drive into a slot, but the mating speed can vary hugely depending exactly how you push it in. It can go from less than 10 milliseconds if you slam a drive into the enclosure, up to a second or more if you partially plug a drive in. And the problem here is that the pin lengths on the connectors are different lengths deliberately, so they meet at different times. And that means that every hot plug will look a little bit different to the system. And the system can respond differently depending exactly when certain pins such as ref clock, burst, and SM bus actually mate. We've also got the drive power and pre-charge pins, and then not simple mating, but we've got pin bounce or contact bounce, which is the action of the gold connectors physically scraping across the top of each other as you push the drive into place. And you can see on the graph on the bottom left there, this is taken from our 2019 white paper on HOTPLUG. This is a scope capture of bounce, and you can see there are multiple transitions before the waveform levels off. Now, if this was on a reset pin, for instance, or on a sideband pin, you could be seeing multiple assertions that the host may act on, which are not real. And you have to be able to deal with that. So why automate it? There are hundreds of possible test cases, as I've said, from very slow to very fast hot plugs, at pin bounce occurring on different pins. Then there's regression testing. Every time you change your firmware or hardware, you really need to run these tests again. Next is the test matrix between different devices. Every SSD and every host will work in combination slightly differently. So ideally, every combination should be tried. And this is going to lead to a huge number of tests. This is something you really want to automate. The importance, of course, is that if there are problems, you want to find it in, ideally, an early R&D phase, well before you start mass manufacturing a product, and you certainly don't want faults to go out in the field. Manual testing is not repeatable. As I've said, every physical hot plug is different. So how do you repeat it? If you can't repeat a failure regularly, it makes it very hard to fix it. What we've seen in the early days before this kind of testing was available is a sort of failure that would happen one time in 1,000 or less, which in the lab you could easily miss. But at the point you've sold 1 million units out in the field, then it starts to be obvious and it can cause serious problems. And these failures can be customer critical, especially when it comes to hot plug on NVMe. In terms of SAS and SATA, hot plug is relatively simple in comparison. With NVMe, there's a substantially higher risk of problems because we are directly coupled into the host's major bus with nothing else in the way in most cases. So we've got the potential for data corruption, memory corruption, blue screens of death, unexpected host restarts and shutdowns. Lots of strange things can happen. And if this is to happen in a critical data center simply because someone plugged in a replacement drive, it's going to be a very grumpy customer. So the way we solve this is through the Quarch breakers. So what we've got is a device that we put between the host and device. So this is our product, our board on the back. There's an ultra-thin flex cable which allows you to route it out of the enclosure, and we can simulate plugs and pools. We can simulate fast and slow hot plugs, pin bounce, and a whole range of other fault injection cases, such as failing one port, one lane, failing a sideband or power, and we can even do basic glitch injection down to around 50 nanoseconds. So a very wide range of faults can be injected with a very simple module. And this is 100% repeatable, and you can run your tests overnight, come back in the morning and look at what you need to deal with. So in terms of automation, we provide simple Python control for your own automation, of course, but we're really talking about QCS today, the Quarch Compliance Suite. And for those customers who don't have the time or perhaps the ability to create these tests, they want some help to get started, QCS allows you to test to the industry specifications, such as the UNH-IOL Plugfest requirements, and our best practice testing from our 13 years of experience in the industry. The idea being to save you the engineering time, find faults earlier in your development cycle, and prove that your products are compliant and robust in operation. So Matt Halsey, who's one of our engineers, has been working on Compliance Suite for the last year or so, has done a fantastic job. So he's going to go through some of the features that we've got. And if we've got questions on the way, then please come in with those. Matt.
Fantastic. So as Andy mentioned, QCS is a very powerful tool. We're trying to make our drives as easy a plug and play as possible. So here you can see the two sides to Quarch Compliance Suite. You have a Java GUI, which is the stuff that you guys will interact with, and you've got a very lightweight Python server, which is run on the host system. So this is cross-platform. The Java client side can be run on both locally or a remote host. And as you can see there, if anyone's used multicast DNS before, we can use this to automatically find the server from the actual client itself. Andy?
Certainly.
So the requirements are quite simple. The Python side requires Python 3. It also requires our Quarchpy package. We upload this to the PyPy repository. So it's brought down very easily via a pip install Quarchpy. The Java side requires Java 8. Now on Windows, we actually include an installer, which bundles Java 8 in the Quarch Compliance Suite package. So you don't actually have to worry about the Java. As I said, this is cross-platform, but all of this setup is available in our quick start guide. However, if you do have issues along the way, you can always send us an email and we're happy to respond. The application itself is licensed. Now, this license is automatically generated for the free tests. However, for the more advanced tests, the pin bounce, the power versus performance that we'll go on to later, it requires a license just because of the collective knowledge and the additional debug that it gives you. The application itself, as you can see down the bottom, is quite easy. The QCS client can again be run locally or remotely. The host runs a QCS server, which is connected to the Quarch module, which is connected to your drive under test. Andy?
Thanks. So as Matt said, this is a partially licensed application. The UNH tests are one of the free ones, so you can take this now, download it in a few minutes, and start running. And any drive that you want to ensure is going to be pre-compliant before you go to one of the Plugfest events, you can do that now for free. The actual license cost itself is actually very low at the moment. As this is a relatively new product for us, we're more interested in getting it out to people, so the cost is very unlikely to be an issue.
So Quarch Compliance Suite displays results in two senses. It has the GUI, which it displays results in, and it also allows you to display results in a PDF report at the very end. We'll explain that later. So the results displays here, it's displayed in a tree table, so you can expand every node on the tree and dig deeper down into the test to see exactly what's going on. Now we aim to be as transparent as possible here. Every single action in the test sends a log here, and a log can be in the form of a description of what's currently going on, a result, pass or fail, and a debug. So debug could be what Quarch commands are being sent across. Our aim here is to try and be as transparent as possible, as I already said, but we're trying to help the customer understand exactly what's going on at every single stage of the test. Andy?
Yeah, so there's a balance here. You know, for those that are not familiar with what they're doing, we want to just make it very obvious that the test passed or that one specific test point failed. But then the idea, as Matt says, is that you can drill into that later, so a more skilled engineer can come along, look through log, and understand what exactly happened. For instance, in the UNH test, it might be one of the very high-speed hot plugs fails. So then you can dig into that, and you can see that the specific failure was the fact that we detected the drive come back at Gen 1 rather than the Gen 3 or Gen 4 it was running at previously, which would be a fail because the drive hasn't enumerated correctly. So there's a lot of detail in the background over what we're testing, which is where the real value from this comes on. You can do all these tests yourself, and the white papers that we're actually writing with these would allow you to do that. But the question is it worth your time and effort going through and implementing all these tests yourself, or can you make use of Quarch Compliance Suite to jump ahead and get the tests done more quickly?
So every single test provides some customizable variables. These can help things like repeats or the time that we wait to find whether or not your drive has enumerated on the system. These have some very good use cases. We'll take the stop on first failure. Say we're at UNH and a drive fails a particular hot plug, fails in the sense that its link speed does not come up as is not maintained. Now we can hit this failure, stop on first failure to be true, and every time that it hits that section, we can leave that drive in the state that it's currently in and allow any drive manufacturer to come along, quickly probe their device, see exactly what's going on, and then rerun the test if need be. Andy? So the UNH-IOL Plugfest, this is a test that most of you guys will be interested in. A quick overview here. The UNH-IOL Plugfest test is a series of fast and slow hot plugs. Each one is performed 10 times. Now, for the drive to pass, it must both enumerate on the system and maintain its lane width and link speed. You can do this manually. As Andy has already mentioned, you can do this via TestMonkey, for example. You can create your own scripts. However, QCS has the additional benefit of going away and checking against LSPCI automatically to find the drive, to find its link speed, to find its lane width, and report all of this for you. So you can essentially start the test, walk away, come back in 5 minutes and see exactly what went on. Andy?
You can really see this at the Plugfest events. You'll find a lot of people gathered around tables doing complicated manual tests. And Matt Station, when he was running this at the last Plugfest that we were able to visit before COVID, it was literally that: press the button and then sit and have a chat with your co-engineer for a few minutes while the tests run. It's that simple. But the UNH test is a basic test, as we've said here. The politics behind this being initially that the NVMe promoters group wanted a hot plug test. They wanted to show that the drives would support hot plug, but they didn't want to risk too many failures, especially early on. So the tests are pretty basic. You're just checking for simple drive enumeration. As Matt said, over a period of 10 cycles of each of the fast and slow plugs. There's no extreme speed plugs included, there's no pin bounce, and there's no running data to the drive before the pull happens. So this is about as easy as it gets in terms of hot plug. And if you want to ensure your drive is going to work in all cases, you will need to do more than this.
So this is where we get onto some of the advanced tests. Tests are always being added to the compliance suite. They're always being maintained, and we're constantly looking back to see if we can add any additional information to the tests that we've currently got out. So a quick overview of some of these. The full range hot plug compliance. It's very similar to the UNH. However, it has a much wider range of delays and timings, so you can get a much wider understanding of what exactly is going on with your drive. The hot plug bounce compliance adds a mechanical pin bounce. As Andy's already mentioned, this is like scraping the device, scraping the pins across each other. Hot plug timing sweep. Now, for this one, we take each individual critical signal and we delay them by a specific amount. This is, again, all shown in the compliance suite itself. And it tries to simulate how a device responds to a host with different signal timings. Now, this has been known to show a few issues here and there, but again, The reason that these require a license is the additional debugging it offers and the increased use cases that you get from this, especially since they're all automated.
And a few issues here and there is probably an understatement. One of the most common things we've had to help customers with has been around specific timings of ref clock versus SM bus versus burst, and exactly when they're asserted, especially during plugs and removals of drives. This is a very common problem. The difference between just 2 or 3 extra cycles of ref clock versus the SM bus when you remove a drive can be the difference between a perfect clean removal and a total system crash. And this is where the timing sweep test really comes in, because it allows you to automate the whole range of these tests and looking for the corner cases where things might fail. But there's more than just that. There's more than just the breakers, and Matt's now going to take you through a little bit of the power-related tests. So for those that haven't seen it, this is the Quarch Programmable Power Module, and there is a new device, the Quarch Power Analysis Module. But both of them are designed for the simple purpose of giving you an order of magnitude more information on what's going on between your host and your drive in terms of power consumption, and with the new Power Analysis Module also in terms of the assertion of the digital signals. Matt, do you want to take me through this?
Andy?
Okay.
Hi, Nana. Have we got questions?
Sorry for the interruption. Yes, there are some questions in the tab. So the first question is how the UNH tests are integrated to Quarch. So that's one of the questions we have.
The UNH tests, was that right?
How the UNH tests are integrated to Quarch.
Sure. So Quarch effectively designed and wrote the UNH test spec for HOTPLUG because of our understanding of what was necessary. So we've been absolutely fundamental to it from the start. It is not currently possible to run these tests without a Quarch breaker because of I don't believe anyone else has actual equipment to control all the signals as necessary. Now that doesn't force you to actually buy it because UNH will perform those tests for you with the equipment that they have there. However, it's generally a good idea, of course, to test in advance and make sure that you're going to pass before you even take a device there. So we are integrated in terms of performing the test in a number of ways. As Matt said, you can run this via our test monkey application, simply manually making the settings, pulling and plugging the drive, and verifying yourself the drive comes back. We have a simple Python script you can download that will run the test for you, again using LSPCI, and of course we have the Quarch Compliance Suite, which implements the same thing again, but with significantly more debug and logging. So there are multiple options there.
Thanks, Andy. We have the next question. I think it's more related. Can we create custom tests in QCS, using QCS?
Currently, no, but that is something we may well be able to do. So what we're looking for initially is to put out the first major range of tests that we know are necessary for people. We are looking towards adding custom code into tests probably in the next couple of sprints, at which point we'll be able to do things, for example, in a HOTPLUG test, to run custom user Python code before and after the test. Now that would allow the user to perhaps run their own debug commands on the drive to verify other things and to then log those as well into the list. And at the point we've got that running, then that is potentially the point that users can actually add their own tests in there as well. So it is on the plan.
Mm-hmm. Thanks for that. There's one more question. Probably we'll take this question, and the others we can reserve for later on. Mm-hmm. The next question is, what is the lowest delay user can set between drive HOTPLUG? So on the original modules, it was 1 millisecond between each ordered pin. However, you can have a 0 delay. You can plug every pin on the connector instantaneously at the same time. So effectively 0 delay. On the modern modules, so the Gen 4 devices and above, we have 1 microsecond intervals. So you could have 1 microsecond between the different pin lengths if you wished. So
slow in terms of data, but very, very fast in terms of a physical, what would be possible in a physical hot plug, far, far faster than you could physically insert something into a system in the real world.
Perfect. Thank you. Thanks, Andy. We'll see the questions later, the rest of them.
Sure. Thanks. Matt, do you want to take us through the voltage margining?
Of course. So as Andy mentioned, we also test power. So he's already explained the Quarch programmable power module that we have. However, on the left-hand side of the screen, you can see our Quarch Power Studio. Now this allows us to actually graph the voltage, the power, the current, alongside any additional data channels that we can find. So as you'll see later, we actually graph the IOPS and the megabytes per second returned from FIO. For this specific test, a voltage margining compliance, we step down the voltage rails in incremental steps over a specific amount of power. So you can specify whether you want 10% decrement or 20, 30, and then you can specify the amount of increments that you want and the repeats on this test. So it's fully customizable, and every single section we would check the power, we would power down and power up and check that the drive maintained its link speed and lane width.
So this is another free test. So it's a very simple one to try out and see the benefit. You know, everyone has to do a level of voltage margining on their drives to ensure their power controllers work within spec. Power Studio is something, again, you can run as a standalone application. It operates like a super long-term oscilloscope trace where you can record power for an almost unlimited period of time. But here we're actually automating it through QCS again. So once again, you get these beautiful traces that you can analyze later, but it's done in a fully automated fashion. Just click and go.
So our newest test is power versus performance. We spent a few months developing this, and what it aims to do is provide a wide range of power. It provides a wide range of power consumption and drive performance on a single test suite. So we run a series of different FIO workloads against the drive under test. These have been found and put into place from queries with different customers, from drive reviewers, and from general things that we've come across and think are of use to you as a customer.
Thanks. And for anyone who hasn't seen it, this is the Quarch Power Analysis module in the bottom. So this is our newest product. It's complementary with the PPMs that many of you may have seen already. The difference is here that we're not supplying power anymore. The power is coming from the host, and we are measuring it as it goes through. So we can't do voltage margining with this device. But we can now measure the interaction between the host and the device. So we can, rather than the drive running off our ideal stabilized power supply, if your host has messy power rails or has dips and glitches, you now see those. You can also measure things like PERST, SM bus, PERST, SM bus, dual port enable, and similar standard sidebands, and graph those as well, so you can see exactly what the sideband assertion timings are in comparison to power, which is very interesting.
So this is an example output on QPS of our 22-hour long run. So this is a full run of the power versus performance. This specific test that you're looking at is a sequential read where we increase the block size. So as you can see, the red line towards the bottom of the graph is IOPS, and it stays the same and slightly decreases as we increase the block size. So you can also see the purple line, which is megabytes per second. So as we increase the block size, the megabytes per second goes up. Now this is great to see visually, especially against the power. So you can see the power consumption increases as we increase the block size as well. Each of this IOPS and megabytes per second data is recorded once per second, but again, it's completely automated via QCS. Is there anything you'd like to add, Andy?
Yeah, so it's QPS, Quarch Power Studio, is capable of adding anything as an arbitrary channel. So here we're adding megabytes per second in IOPS, but you could be adding drive temperature or any other item that you're particularly interested in here. And the visualization is fantastic. There's almost no trace that we've taken here that hasn't had some fascinating things to look at. And the obvious one here is that the megabytes per second rapidly increases with the block size. Power consumption increases, but at a much lower rate. So we can see this drive has substantially higher efficiency at larger block sizes, which probably isn't surprising, but here we can measure exactly how much that's the case. And you can see from the red markers here, we are annotating the start and end of each workload. So you can see exactly where the workload specified in the compliance test, or your own markers that you put on, exactly where they fall onto the trace.
QPS is also really good for us in the sense that it allows you to see statistics of the data that was recorded. So this can be the mean, the min, the max, and it can also do this of the custom channels that you've created. As it says here, it's very easy to find the best and worst cases. In the last trace that you just saw, you might have seen a few spikes where we can look straight into this statistics grid and we can find the exact power consumption, or the exact max power consumption that occurred across that test. This statistics grid is actually queryable, so you can write Python code to query this via the QPS API. Andy? Now, this is great with QCS, well, when combined with QCS, as we can integrate additional things like the FIO results. So here we supply it in a very easy to read PDF report. This statistics grid, table, you can see we give an overview of what exactly happened throughout that specific test. So the average read IOPS stayed the same on this sequential read test. The block size we increased. The average read megabytes per second doubled effectively. The average power stayed pretty much the same. So again, you get this very easy to see, very easily readable view of, hey, my drive was almost twice as efficient at the higher block size. So the PDF report is individual to every single test. We do provide that little header, as you can see on the bottom right. This includes stuff like whether or not the test failed or passed, what exactly failed and passed, a little bit about the drive, a little bit about the host, and a little bit about what Quarch module was actually provided. So we do aim to keep updating this over time. If there is any additional information you guys would like to see on these test reports, by all means recommend and query it with us, and I'm sure we'll be happy to add these. Andy?
Thank you, Matt. And yeah, that takes us to the end of the slide deck, and thank you very much. Main thing to remember is we're always here for support. If you've got a copy of these slides, which I'm sure you can get from me, our direct emails are on there. If you want to contact myself or Matt directly with questions, you're absolutely able to do that. We're very big in our support at Quarch. We want to make sure that the engineers can talk directly with our customers and solve the problems, and you're always welcome to do that. Nina, are there any other questions we need to cover?
Yeah, thanks, Andy. So I think there are a couple of more questions we could answer. The first one is, do you also support test cases for Gen 5 standards?
Absolutely. We already have a Gen 5 slot module, so that's a by 16 PCIe slot. We are currently working on both a light version of the Gen 5 slot card, which will be a lower cost version for simple HOTPLUG, and also on Gen 5 U.2. So those are both under development at the moment. And then I think next after that is going to be E1.S and E3. I'm not certain of the exact schedule. If there are specific Gen 5 interfaces that you want us to cover, and you know they're coming up soon, please let ESA know or us directly, and they can feed back as to which versions we should work on first.
Okay, perfect. Thanks for that. And the next question is, which Quarch modules support QCS?
So QCS supports any of the standard breaker modules for HOTPLUG. So the current HOTPLUG test, especially the likes of the UNH one, will work with any of the standard breakers. So it could be E1.S, E1.L, it could be M.2, even though an M.2 interface doesn't generally support HOTPLUG, the breaker will work with it. It will remove and insert the device as normal. In terms of the power versus performance tests, again, it will work with all of our standard power modules other than the very original PPM. So it'll work with the XLC, it'll work with the HD, it'll work with the new PAM as well.
Okay, thank you. The last question we have is, can we get the report in PDF format, in a downloadable PDF format?
Yes, you can. As Matt mentioned, there is a, this is just a snippet of the output of the power versus performance report. So yes, the primary report is recorded in PDF format for you.
Okay. There's just one more question. They want to know about the test suites that are covered. Probably if we can mention a few of them.
So Matt did go through most of the test suites that are there at the moment. Obviously we've got the UNH-HOTPLUG compliance test, which is the compliance for the UNH-IOL HOTPLUG. We have the full range HOTPLUG compliance test, which again Matt mentioned, which is an expansion on that to cover all the HOTPLUG timings that we think you should be doing, not just the basic UNH ones. We've got the bounce during HOTPLUG. So the intention of that is specific to, I don't believe that's specific to U.2 anymore, is it, Matt?
No, sorry. It's every drive is recognized when it's plugged in, and every test is able to pass every single drive, every single module. Sorry.
Just know the picture. That's all. That's fine. So yeah, so we've got the bounce. So that will bounce each pin that is available for control of the module during plug to look for any issues around that, and so it'll work with any of them. We've got the timing, the signal sweep, which is setting the connection timing of each critical signal, both before, through, and then after the other signal. So it's both connected earlier and later than would normally be expected to look for corner case failures. Then we've got the voltage margining test, another free one, which allows you to test your drive's ability to work at slightly lower voltage levels. And we've got the power versus performance test, which is our newest one, and really shows off the abilities of Power Studio and the power modules to understand the power versus performance effect of your drives. So there are more coming. Matt, do you want to touch briefly on the tests that you're working on specs for at the moment?
Sure. So currently we are trying to do a link speed test, which, if I remember properly, we are dropping specific data signals in different use cases. So for example, dropping the data, making sure the drive is not powered up with data 3, for example. And then also removing the data lane while the drive is actually idling, and another use case where we remove it while it's under a workload of some sort, so we can measure the link speed and lane width, whether or not it's maintained. We have got a few more in the pipeline. Most of them are just in early specification stage, so we're constantly undergoing more, but we're welcome to, we are more than willing to accept recommendations for anything that is seen as useful to you guys.
Yeah, one of the things we've seen a lot of interest at the moment is around the power loss circuitry. You know, how can we stimulate the drive's power loss protection circuitry to ensure that there's no data loss on the drive across a range of sudden power loss events. The programmable power modules, as well as just margining, is capable of very sharp glitches, so we can simulate sudden power loss or sort of crowbar events where power rail is pulled down hard as well, and we can use that frequently to the point that you can force a hard failure on a drive. So we're looking to create a series of tests there that are non-destructive, but ensure that the drive actually protects its data in every reasonable power loss circumstance.
Yeah, thanks, Matt. Thanks, Andy. I think that was more detailed explanation. We have a couple of more questions. I think they're interesting. The first one is, should UNH-IOL QCS be run on UNH systems, or can it be run on a Linux environment?
It can be run on a Linux environment. It is, as Matt said, it's designed to be cross-platform. It's also possible to run the front-end control completely separate from the back end. So you can run on any system you want within reason.
Okay. The next question is, does advanced tests have cross-feature testing, that is HOTPLUG during IO workload, and any other protocol spec commands?
So we don't have HOTPLUG during workload at the moment. That's something I would love to add, and it's something we're certainly looking at. At the moment, though, it is just in an idle state.
Okay. There's one more question again. Can we enable or disable dual port pin on drive if drive is dual port capable?
Yes, so with the newer breaker modules, you have control over the dual port pin, so you can connect and disconnect it. And with these newer versions of breakers, we also have a feature called driving. So with the sideband signals like dual port enable, we can actually drive it high and low as well. So you can actually force the drive into a particular state. Similar with the burst pins, for instance, you can, as well as just disconnecting the burst pin, we can actually drive it, which means disconnecting it and then driving it low for a set period of time, so you can force the drive into reset.
Mm-hmm. Yeah, thanks, Andy. I think we have all the questions answered by now. Yeah. So
great. Thank you, Anna,
yeah,
for hosting this.
Yeah. Thank you, Andy. Thank you, Matt. We thank all the attendees for spending time with us to learn more about Quarch solutions. We're very pleased with all the interest we've been receiving from you about Quarch solutions. We just wanted to let you know that we have the evaluation units locally available with us. So please feel free to send us the evaluation requests. We look forward to working with you for your test initiatives. So we'll share the deck and the webinar recording shortly. Thank you again. All of you have a good day.
Thank you, Nana. Thank you, everyone.